announcements to go through today, so let's kind of just step through these. First of all, homework 7 is due on Wednesday. Make sure you're able to do that. There's going to be some questions at the end that we won't get to probably by the end of class today. So if it says like section 8.2, just know you probably can't do it, okay? If it says like section 8.1, you quiz 5 is, well, I guess today, topic will be on confidence intervals, just like our quiz review. And test 2 is coming up. So I actually have a study guide for you guys. Let me just pass this one out. Don't be scared that it's kind of a thick study guide. I just try to make enough space for your answers. 1, 2, 3. And let's just go through this. There's some important information on here. So at the very top, okay, big thing, you are going to be allowed to bring a 3x5" note card to the exam. Okay, you can write on the front, you can write on the back. I don't really like, you can write on both sides if you want, and you can write anything you want. Okay, so I just feel like I'm confusing. Okay. So bring a 3x5" note card to the exam and write any notes on it that you want. Okay. The test won't be in here. It'll be in Henson 150, the same room that we took testimony in. Okay, and it will be on the computer. You can bring a calculator, or you can just use like Google Calculator if you want. Okay, either one is fine. Okay. Well, I don't know who Mason is. That's weird. Okay, hopefully it's not a Zoom crasher. Haven't had one yet. Okay, so going down, there's a lot of topics. I know. Don't be scared that there's a lot of topics. Use the study guide to help you prepare. Okay, a lot of these are kind of like Minitab commands. You know, applying an equation. Okay, if we go down here, I think the probabilities are a little bit weird. Let me just make sure. Yeah, okay. There's normal stuff, central limit theorem, and confidence intervals, okay? We will see how far we get into chapter 8. If we don't get to something in chapter 8, then of course, you're not going to be tested on it, okay? But for now, I just put everything in chapter 8 that you need. Okay. And then over here, we have some practice questions, okay? Just like test 1, remember, these practice questions are to guide you through some questions that I might ask you, okay? I try to make them help you give an idea of what might be on here, okay? So I want you to do well. Make sure you go through this. I will post the answers by next Wednesday. If you have any questions on any of these questions, either come to me or go to the tutoring center. You can ask them, they can help you out. Okay. Any questions on the test? Okay. All right. So let me move this over here. Let's see, another announcement. Minitab Lab 3 is due on Monday, so make sure you start working on that. It's due at the end of the day on Monday. Make sure you get to a campus computer. I know Minitab's a little bit weird. So make sure you get Minitab in. And okay, I do have an extra credit opportunity for you. This will be due the last day of class, okay? I have been struggling trying to find extra credit opportunities this semester. Last semester, there were a lot of like donation drives and stuff that were going on that I was able to do. This semester, I can't really find much, okay? So I've dug around in my brain, and my extra credit opportunity for you is a MART project. I swear to God, this is not an April Fool's, okay? I know it sounds wacky, but I think it might work. Okay, so let me get this loaded up here. So if you just go in my classes, go to assignments, you can read through this assignment that is taking forever to download. Oh, there we go. Okay, so this is going to be due last day of classes, Friday, May 13th at the end of the day. Okay, just a little disclaimer, if this is not up your alley and you don't want to make an art project, I completely understand, but talk to me and maybe we can find another idea. Okay, I just can't really think of any other ideas for extra credit. Okay, so MART is a new kind of thing in mathematics that people have been using. It kind of just combines math and art. So art that's inspired by different math topics, okay? There's a lot of information that you can read about this. And this extra credit opportunity is just gonna allow you to, I don't know, create your own MART, okay? Now, the rules for this are kind of relaxed, okay? I don't wanna limit your creativity on this. But basically what I want you to do is to choose some sort of topic. It might just be statistics in general, but I have a couple examples, like maybe z-scores or percentiles or the normal distribution. I want you to choose something that inspires an artwork, okay? Now the art doesn't have to be like coloring a piece of paper, like you could, I don't know, glass blow something, okay? I don't really care what it ends up being, as long as it's some sort of art and it's inspired by something in statistics, okay? This is going to add, okay, if you do this project, I'm gonna have it count 4% to your final grade. So at the end of the year or at the end of the semester, whatever your grade is, I'm just gonna add 4 percentage points, okay? Some guidelines, okay? Your project can be of any form, okay? If you wanna sculpt something or even write something, I don't really care. You can write a story about statistics, create a comic, do a dance, create some music, I don't really care, as long as it's something about statistics, okay? You can work together on the project, but the project that you turn in has to be like your original work. If you want to team together with someone, just let me know. You can hand your project to me during class, or you can just take a picture of it or upload a file to the My Classes site. Okay. To get all 4 pieces of extra credit, I want 2 things, okay? The first thing is, well, your art has to look like somewhat neat, okay, or somewhat like you put some effort into it. As long as you put like an hour into your artwork, I'm fine, okay? I'm not gonna accept like a doodle or like a scribble on a piece of paper, okay? The other 2 points are gonna be just writing a paragraph, a couple of sentences that explains how your project relates to the math subject, okay? So just explain what it means, how it relates to the subject that you're doing, and make it like 4 sentences long, okay? So at least 4 sentences long, I think that'll be good. Okay, now I know it's kind of confusing, so I'm gonna give you a few examples of MART that people have used before, okay? I know this sounds kind of weird, but okay. So this is an example. This artist tried to illustrate the first 1,000 digits of pi using colors, which is kind of cool. So instead of writing 3.14159, he made like orange stand for 3, pink stand for 1, and kind of just put all the digits of pi in a nice pattern here. So I also put an example paragraph with what might be good for this. I know that's not really statistics related. This one isn't either, but I thought it was kind of pretty. And this person worked with the absolute value symbol, which makes things positive. And I don't know, I thought it looked kind of cool. Put it in a little frame and said, avoid negativity. Okay. Examples of statistics ones. This one's kind of weird, but they took the normal distribution and like added words on top. I thought that looked kind of cool. This one is a scatter plot, but then they showed an outlier in red on top. So it's kind of just showing that maybe being normal isn't like too bad, right? It's kind of awesome. Okay. This one's an example of something that isn't like a sheet of paper with like colors on it. Someone actually took a bunch of normal distributions and like pieced them together, which I thought looked really cool. Okay. Finally, you could like get actual data values and like kind of arrange it in a way that looks cool. So we learned about like bar graphs and pie charts and histograms and things like that. This person decided to make like a really cool graph that looked a lot better than like your traditional histogram or bar graph. Okay, so I thought this one was kind of cool. Okay, now just to make it clear, if you do something like this, I can't give you points. Okay, I think you guys get the idea. It's got to look like you put some effort into it, but I'm pretty relaxed on this. Okay. So I know that there's not many guidelines. If you have any questions, just talk to me about it. If you want to do something else, I completely understand. If you come up with a good idea, just let me know. Okay. Any questions on extra credit? Okay. All right, so I think that's the end of the announcements. Yep. Okay, so what we're going to do here is I'm going to share my screen. Okay, and we're going to continue our notes from last class. Okay, yeah, raise your hand if you don't have the notes and you want me to give you one. Anyone else? All right. Okay, so we've been doing a lot of different calculations in this class. I think we finally have gotten through this idea of a confidence interval. We can relate it to that show called The Price is Right, and that gives us really good intuition of what we're actually doing. Okay, we can combine our symbols together and come up with a way to create a confidence interval, which is like a range of numbers that we think the population mean or the thing we're interested in is in between. Okay, so we did a bunch of work. We have these charts and we combine everything into this procedure that is your quiz that will lead you through creating confidence intervals. Right? We check our assumptions, we find the critical value, we find standard error, the margin of error, and then we use that to create our confidence interval. We also have a way to interpret our interval in words. Okay, so bringing us back to speed on this, we did a couple examples of this. And now we're gonna do some more conceptual type of problems, okay? There's two other things I might ask you about confidence intervals for this section, okay? So the first thing that I might lead you through, okay? When we did the Price is Right game, we talked about how meaning and the size of the interval had a balancing act, right? The larger our interval, the less meaningful it becomes, and the smaller our interval, the more meaning it has, right? It means more to win the Price is Right if the interval is very small than if the interval is really large, okay? So that's why a big margin of error isn't the best thing, okay? A small margin of error has a larger meaning than a large margin of error, okay? And I kind of want to lead you through how the margin of error affects the size of our interval, okay? So I'm gonna write here the margin of error, okay? I'm just gonna call it M for now because I'm kind of lazy, I don't feel like writing it, okay? Let me ask you a question, okay? Let's say I have two scenarios. I have a margin of error that's 2,000, so it's very large, okay? And then I do another interval with a margin of error of 0.0001. Okay. Which interval is going to be bigger? The 200 or 2,000 or the 0.001? The bigger, the 2,000 one, right? Because the margin of error is what we add and subtract to the point estimate. So the larger it is, the wider our interval is going to be, right? So if we did our interval here, our margin or our interval will be really large. Okay, now if we have a very teeny interval, our teeny margin of error, our interval is going to look very small, right? That red interval is going to be very, very narrow. Okay, I'm struggling to write because I dropped my Apple Pencil and it like dropped right on the very tip of it. So it's very sad for me. Okay, so whenever I talk about the margin of error being really big or really small, it's the same thing as saying that the interval is really wide or really narrow. Okay, any questions on this? Okay, now here's where things get a little bit trickier, okay? The best way I like to conceptualize this is by looking at the relationship that margin of error has with different values, okay? I'm going to look at how the margin of error correlates with the confidence level, and I'm going to look at how it correlates with the sample size. Let's start with confidence level. When we did these problems, confidence level was like the 98%, the 80%, the 20% that was given to us in the question, right? So let me just give you an example. Confidence interval, 98%, 90%, etc., right? Let's take a look at what this is saying. Here, I'm gonna write something down and we'll fill in the blank. Okay, so when things have a direct relationship, for example, confidence level and margin of error, as the confidence level increases, what should happen to the margin of error? They correlate directly with each other. Any guesses? It goes up, right? So when something has a direct relationship, as one thing goes up, the other thing also increases. Okay. The same thing goes if it decreases. As the confidence interval goes down, the margin of error will go down. Okay, so this is what we mean by margin of error and confidence level having a direct relationship. Okay, let's take a look at the second one. Okay, let me write this down here as sample size blank, margin of error blank. Okay. These two have an inverse relationship, okay? So as the sample size increases, what do you think happens to the margin of error? It will decrease, good. Right, so when things have an inverse relationship, remember inverse is like the same as invert or reverse or turning upside down, right? When things have an inverse relationship, they do the opposite, okay? So as the sample size decreases, the margin of error will increase. Okay, so these two react oppositely. Okay, now I didn't have to write the margin of error because the margin of error does the same thing as the interval. So we can also read this as the sample size increases, the margin of error and the size of our interval increases or decreases, right? It gets nearer. Okay. Let's do a few examples of this. I think it seems like a very easy concept, but for some reason, my mind doesn't process it very quickly, okay? So I have to write stuff down. Here's an example. We have this guy, Greg. He makes a confidence interval using a sample of size 30, okay? Let's say he made another one with all the same information with a sample of size 100. This question is asking us, would the confidence interval be bigger or smaller, okay? Now, I know you kind of want to jump to conclusions with this, and if you're very good at it, I don't really care how you do this, but I'm going to do this step by step because I'm not very good at doing this myself, okay? So let me just write what happened to the sample size. The sample size blank. Did it increase or decrease in this scenario? It increased, right? We started out with 30 and then the sample increased to 100. So the sample size definitely increased. My goodness. Okay. Okay, since the sample size increased, let's see what happens to the margin of error. Okay, do you think the margin of error is going to go up or is it going to go down? It's going to go down, right? Because the margin of error has an inverse relationship with sample size. So because sample size goes up, margin of error goes down, decrease. Okay, and since the margin of error is getting smaller, is the confidence interval getting wider or narrower? If the margin of error is getting smaller, is the confidence interval getting big or small? Small, good, because a small margin of error means a very narrow interval. Okay, so the interval will be smaller. So our final answer is that the interval gets smaller. I know you might think I'm really dumb for doing this. I probably am, but if you can do this in your head, I encourage you to do that. If you need to do this, I completely understand because I do that too. Okay. How about this? Try example 7. This one's dealing with the confidence level instead of the sample size. Try to see if it gets bigger or smaller, and I'll come back to you in a bit. Come back to the front. I'm seeing some good answers around here. Yeah, let's take a look at this one. Okay, so here we have Regina. She makes a confidence interval using a confidence level of 95%, but then she increases the confidence level to 98%. Okay, now we're asking if the confidence interval is going to get bigger or if it's going to get smaller. Okay, this is slightly different than example 6. How is this question different? What's changing in this question as opposed to example 6? The confidence level, right? So over here, the sample size went from 30 to 100. Here, it's the confidence level that goes from 95 to 98. Okay, so instead of writing sample size up here, I'm going to write that the confidence level, and I guess it increased, right? It started at 95 and then it went to 98. Okay, so it increased. Okay, sometimes I even need to write how it increased 95 to 98. Okay, so this level increased, okay, and now we're asking ourselves what happens to the interval, okay? Now going up here, it says that margin of error has a direct relationship with confidence level. So did you guys say the margin of error increased or decreased here? Increased, good. Remember, direct relationship does the same thing. So the margin of error increases. Okay. Since the margin of error is increasing, let's see. Will the interval get wider or narrower? Wider, right? It's going to get bigger. That is not grammatically correct, but that's okay. Okay, so our final answer is that the confidence interval is getting bigger because the margin of error is increasing because the confidence level increases. Okay. Any questions on how I got to example 7? Awesome. Okay. So that's the first kind of conceptual thing we're going to go over. You'll see some of these questions on your homework. Just go through this sort of thought process. Okay. The last thing we're going to do is, well, we're going to talk about the sample size, okay? In a lot of situations, we don't like create the sample size first and then find the confidence interval. That's usually not what we do, okay? Usually what we do when we create a sample is we first decide how big we want the sample to be, right? For example, if I wanted to take a sample of 3 from this class, or sorry, if I wanted to take a sample of this class, I would want to figure out how big my sample was so I can figure out who I'm taking and how many people I'm taking out in my sample, right? Okay. So let's read what this is saying, okay? If M is our margin of error, M for margin, right? And we want to know, like, we want to know the sample size needed to get that specific margin of error. Remember, margin of error depends on the sample size. What we're going to do is plug everything into this formula here. We're going to take the critical value, multiply it by the population standard deviation, divide it by the margin of error, and square it. Okay. So this is how we'll find the exact sample size needed to get a specific margin of error, a specific width of our interval. Okay. Now, this is a minimum margin of error. Whenever we're asked about a question that talks about the minimum number needed, especially if we're talking about something that's a whole number, for example, the number of siblings you have, you can't have a decimal answer because that wouldn't make sense. You can't have half a sibling. Okay. What we're going to do is we're going to round up our answer to the nearest whole number. Okay, and I really want you to circle round it up. Okay, since we're talking about the bare minimum needed to achieve something, we're not going to round down even if our number is below like a 0.5. Okay, so we're always going to round this number up. Okay, if that doesn't make sense, I think the example will show what we're doing. Okay. Let's do a little example. So, oh, one more thing. I do want you to either memorize this formula or write it on your cheat sheet, right? So memorize or write it on your index card. Okay. Example 8 says, we have scientists and they want to estimate the mean weight of mice after they've been fed this special diet. That's kind of sad. Anyway, from previous studies, it's known that the weight is normally distributed and it has a standard deviation of 3 grams. Okay. So this is a standard deviation. Is it the population standard deviation or the sample standard deviation?
It says previous studies, so that we sample.
You're really close.
Not sample, but population.
Yeah. So because it says the previous studies, well, that's like before we even took our sample, right? So whenever we're using the word previous, that's a good hint that we're using the population standard deviation. Okay, so that's kind of like a big hint here, right? This is asking us how many mice must be weighed so that a 95% confidence interval will have a margin of error of 0.5 grams. Let me write this down. We have a 95% interval, and the margin of error, or M, is 0.5. Okay. So is everyone good with the symbols that I'm using here? Cool. Let's take a look at this formula. We want to find N, the left-hand side. We know, let's see, we know what this symbol is, the population standard deviation, and we have the M, but we don't have the critical value yet, right? That's something that we don't know yet. How would we find that? How do we find critical values? Good, the chart, right? So can someone look in their chart and tell me what the critical value for a 95% interval is? Awesome, 1.960. Okay, so for these types of questions, usually they're not going to give you what the critical value is. They're going to give you the confidence interval or the confidence level. Okay, so this is found using the chart. I think now we have enough information to plug everything in because, well, we have the critical value, the population standard deviation, and the margin of error. Okay, so N equals. Let's plug things in. Critical value is 1.960. Okay, I'm going to multiply that by the population standard deviation, or 3. And I'm going to divide by M, 4.5. Okay, don't forget the square on top of that formula too. Okay, so all I did is just plug everything into the formula. Okay, well, let's see, 1.960 times 3 is 5.88. So I'm just going to write that on top. I know doing every step like this is kind of tedious, but sometimes it helps me out. Okay, then I do the division, 11.76 squared, and that ends up being 138.298. Okay. So 138.298 is the minimum amount of mice I can use to get this specific margin of error. Okay. Now, we can't have 0.298 of a mice, right, from a mouse. So we need to round this up. What would this round up to? Even though we're not rounding down, we're rounding up. Not quite. 139. Yeah. I sometimes, actually that is rounding up, but it's just rounding up to the nearest 10. Yeah. Yeah. So this would be 139. Even though that number is 2, we're rounding up, so this goes to the higher number. So 139 mice is the minimum amount for this question here. Any questions on this one? All right. Try example 9. I'll be around to look at your answers, and I'll have you give that one a shot. All right, let's come back to the front here. Okay, so we're looking at the average length of roosters in Canada, a very specific type of question. We already know that the length of roosters is normally distributed. It has a population standard deviation of 6. I always like to write down what I'm dealing with. Okay, we're asking how many roosters should be in our sample so that a 50% confidence interval will have a margin of error of 25.8. Okay. So this gives us a lot of information, but not enough to plug in yet, right? So the best thing to do here is to find the critical value. What did you guys get for the critical value? Okay, awesome. 0.674. Awesome. Okay. Now we have enough to plug in, right? All we have to do is look at our formula and put in the critical value, the standard deviation, and m, or 0.8. Don't forget to square it. Okay. So what did you get when you did all this calculation? What was your final answer? Or with the decimal, by the way? I didn't get that one. Did anyone get anything different?
25, 23.
Good. Yeah, sometimes the calculators can be kind of weird. I think you had your setup right. Okay. So 25.55, but we can't have a fraction here. So you rounded it up to what number? 26. Good. Okay, so our final answer here is 26. All right. Any questions on example 9? All right. So I think next class we're going to start chapter 8.2. Okay. I don't know if we'll be able to get through all of it. Just remember, I'm not going to test you on something I did not teach you. Okay. So don't freak out if there's something that we didn't cover on this pair of notes on the study guide. I promise I'll take it off if I decide to spend more time on this section. Okay.